Okay everyone, today I'm going to be seeing if I can stack Pringles in a complete circle with no glue, just balanced by gravity alone. And then I'm going to talk about the reason behind why it's possible to completely stack Pringles in a complete circle without them falling. And a cool result if I am able to do it, we all know that Pringles are curved, but what's their radius of curvature? So if I can get a full circle, I'm going to measure their radius and we'll know what the radius of a Pringle is. I've never done this before, but I think it is possible. Let's go ahead and give it a try. So the key at the beginning, I think, is to get a strong base. Oh yeah. Look at that. Perfect ring of Pringles. Okay, so now with this complete, I can go ahead and measure the radius of the curvature of a Pringles chip. Now there is some gaps and imperfections in this, so it's not going to be exactly correct. So I can measure the radius here. The diameter is about 11 centimeters. So that means the radius of curvature of a Pringle is about 5.5 centimeters. So seeing it like this, it's easy to understand what radius of curvature means. Even if it's not a complete circle, when something is curved, you can still define its radius. So how are these chips able to stand up like this? As long as the center of mass of one chip does not fall over the edge of the other chip, then it will stay up. So here's what I mean. So I have a bunch of sticks of equal length here. So if I want to stack them on top of each other without them falling over, I have to make sure that the stick on top, the center of it, does not pass the edge of the stick below it. So as long as I don't do that, it won't tip. But if you stack another stick on top of it, then it gets a little more complicated because you've added weight to the stick below it, so now the center of mass of these two sticks is over the edge and it causes it to tip. So the question is, how far could you project these sticks without them tipping over? And the answer is surprisingly far. So you can see that with just 7 sticks, I'm able to stack them so that the top stick is completely over the edge of the bottom stick. And there's actually no limit to how far you could continue to stretch this out. So you can see that with more than one stick, it gets very complicated of how far you can overhang the top stick. But there's actually a pretty simple formula to follow to figure it out. So what the formula says is the nth stick can stick out 1/2n sticks. So if you just have 2 sticks, the top stick can stick out 1/2n, and n is 1, so it can stick out 1/2 length before it tips. If you go over 1/2, it tips. If you don't, it doesn't tip. But if you add another stick now, so now for 3 sticks, the top stick can stick out 0.50. The middle stick can only stick out 1/2 times n, and n is 2, so it can only stick out 1/4 from the stick below it. And that's just what we see with 3 sticks, is that the middle stick can only stick out 1/4 from the bottom before it tips. If we make the middle stick stick out any more than 1/4, then it tips. So what happens as n gets really large, if you add more and more and more sticks, is there a limit to how far it can go? Well, the answer is actually no. So this formula diverges, meaning there's no limit to how far the sticks can stretch out without tipping over, as long as you have enough sticks. But the formula diverges very slowly. For example, if I wanted to have these sticks stick out 10 stick lengths from the bottom one, I would need 1.5 times 10 to the 44 sticks. So the way you get this formula here is just by saying that equilibrium requires that the torque due to the weight of the nth stick cancel the torque due to the weight of the top n minus 1 sticks. So what's different from Pringle stacking compared to the stick stacking is that gravity changes the way that it's pushing down on it so that the chips start to slide. And if you don't want the chips to slide, you have to put enough frictional force on the side of it so that gravity can't push it down. Just like if I don't want this Pringles can to slide down the chair here, the only way to stop it from sliding down is I can create a frictional force up that's greater than gravity force down. And the way I do that is just by pushing against it. So when you push against it, the reason it's not going down anymore is because there's a force holding it up, and that force holding it up is friction. So even though you're pushing this way on it, the only force that's keeping it up is the friction from the back of the chair on the Pringles can that's pushing it this way, while gravity's pulling it that way. And that's the same thing that's happening when the Pringles start to get vertical, is that you have to get enough Pringles pushed against the side of them so that they have enough friction so that they don't slide back down. Hey everyone, thanks for watching another episode of the Action Lab. I hope you enjoyed it. I hope you learned something. If you did enjoy it and you're not subscribed yet, remember to hit the subscribe button, and you can hit the bell to be notified when my latest video comes out. And you can comment in the comment section with any questions about this video or any suggestions for future videos, and I'll try to get to them. And thanks for watching, and I'll see you next time.